we as a company, we want to be the entry point for data for all data-driven applications. That's a big statement.
Hello and welcome to episode 68 of Great Things with Great Tech, the podcast highlighting companies doing great things with great technology. My name's Anthony Spiteri, and in this episode we're exploring the exciting world of open source data orchestration for analytics and AI in the cloud with a company that's revolutionizing the way data-driven applications and storage systems interact and process data at unprecedented speeds. What started out as data acceleration is now touted as a high-performance data access layer. That company is Alluxio, and I'm delighted to be speaking with Director of Product Management, Adit Madan. And welcome to the show, Adit.
Hi, Anthony. Thanks for having me.
Hey, great to have you on. Just before we get into Alluxio, if you love great things with great tech and would like to feature in future episodes, you can click on the link on the show notes or go to GTwGT.com and register your interest. Just as a reminder, all episodes of GTwGT are available on all good podcasting platforms, Apple, Google, Spotify, obviously all hosted and distributed by Spotify Podcasts. And as a final reminder, on YouTube, head to GTwGT Podcasts, hit that subscribe button and the like button so you get all past and future episodes. So with that, Adit, let's talk about Alluxio and, give us a little bit of a background about the company's founding to start with. And then I'm really interested as to, how you got to be, where you are in the company.
Cool. So Alluxio started from UC Berkeley's AMP Lab. So University of California, Berkeley has a lab called AMP Lab, which also gave birth to other prominent projects at the time. So there was the Spark project, which, as you all know, is the company that is the project behind Databricks, and that's where the founders for Databricks come from.
Oh, okay, cool.
So they were responsible for building the compute side of things, and there was another company which came out of the same lab, which was Mesos and Mesosphere, which rebranded itself as DCOS. So those guys were responsible for what they call resource management. Once you have a cluster of large nodes and you're computing using frameworks like Spark, how do I task things out and distribute it to a cluster? And we were the third major project to come out of the same lab, and we chose to take a different direction than other than just building another compute framework, and rather than building just another storage framework, we decided to build something which sits between computation and storage.
Okay, and that's interesting. And those are two, pretty big sort of companies and names in the IT industry. So you're in some pretty rare air there in terms of the project at Berkeley. And you've got two co-founders. Just what are their names and what was their background?
Yeah, so our co-founders are Haoyan Lee, HY as we call him. He was part of the AMP Lab at Berkeley. So he worked closely with Professor Ian Stoica and Professor Scott Shanker. As you know, Ian Stoica is on the board of Ray as well as Databricks. So he worked closely with a lot of prominent names in the industry. And he started off the project as part of his PhD thesis. So Alluxio was actually named Tachyon back then. This was back in 2014 when the project started. And we called it a memory speed virtual distributed file system at the time. So virtual distributed file system is kind of the technical name of the project. So this started back in 2014. Our other co-founder is Amelia Wong, who also comes from Berkeley.
That's really interesting, and I think Tachyon the name, I think from memory, not to sort of pardon the pun there, but I think I do actually remember that as a name because I've working in infrastructure back then, working on hosting platforms. I was really interested myself in utilizing memory for quicker, disk access, and a company called, I don't know if you remember Pernix Data.
Yes,
Pernix
I do.
Data basically
Hmm.
did a similar sort of situation, but they used memory and flash disk to be able to
Hmm.
accelerate data before. And is it sort of the same idea as that, or was it something slightly different, or where did Pernix and Tachyon sit next to each other? I'm just interested in that.
Yeah, so the Tachyon so Tachyon itself has an interesting story. This is a little bit of a digression, but since we're on
No,
Tachyon,
we love digressions, yeah, for sure.
so Tachyon was our initial name, as you know. Uh, so we actually ran into trademark issues with the name Tachyon. That's why we rebranded into Alluxio. And
Okay.
Alluxio is not a real word. It's a made up word. And the reason we chose that is because we wanted to avoid all trademark issues. So we thought about Alluxio as all users need I/O, and all UX I/O is what Alluxio is.
Hey, that's pretty good. That's one of the better ones that I've heard out of 68 episodes. That one is a good story in terms of, why a name is a name. So that's pretty cool. Because sometimes, well, in that fact, it's not really that made up, is it? It's actually, pretty much explains what the company does from that point of view.
Hmm.
So not too bad from that point of view. So in terms of where the company started to where it is now, what was the problem statement that I guess the project, the company, the technology was trying to address in the early days to start with?
Yeah, so when we started the company, we were really closely tied to the Spark project. We were actually the default data layer for Spark, and a lot of the Spark internal processes went through the Alluxio file system at the time. So Alluxio's goal when it began was actually to accelerate and speed up Spark computation jobs. And Alluxio came in as a flag as part of the Spark distribution itself. So you could just say something like turn on Tachyon, and you would have the system that we have running as part of Spark. And since then, the company has evolved a lot to really cater to not just Spark, but the larger ecosystem that we have out there. One of the major bets that we took as a company was that the data ecosystem is going to be extremely diverse. So our prediction is that every 3 to 5 years, there's going to be a new compute framework and a new storage technology, which is going to come in and disrupt the industry. So that's why we position ourselves as something which sits between computation and storage and is agnostic to compute as the compute changes on top.
Yeah, so maybe just explain a little bit about technically what the platform is and what it does and how it does sit in between those two, the compute and storage layer that you've talked about, because I think it's really interesting.
Yeah, so what we provide as a technology is to boil it down into simple technical terms. It's an extremely scalable distributed cache, and it provides a universal endpoint for all of your data. So the combination of these two things is a really powerful concept, which allows enterprises to be agile with their platform. So with the cache, what we get is that you have the flexibility of moving your computation to anywhere. So if you have a computation spread across multiple regions in AWS, you're able to access your data from silos which exist without Alluxio. And with the universal endpoint, what you get is that you have access in the same manner to data, no matter what the source is. So it could be coming from a storage system like a MinIO. Could be coming from Amazon. It could be coming from GTS. You have the same endpoint regardless of where the data is coming from.
Okay, so I mean that's like an heterogeneous data platform, right? Is kind of how you'd explain it. Is it a distributed file system as such in that way, or is it something a little bit different to that? Because I think of it when you talk about underlying different types of storage being produced and sort of given as a single namespace. I do think distributed file system is that accurate to say that Alluxio is that?
I would say that as soon as you add like with the initial tagline that we used for the company was a virtual distributed file system. So the word virtual means that it's not a distributed file system, but it pretends to be one. So
Yep.
even if it's accessing different kind of file systems underneath. So virtual the file system, I would switch it up into these days as people use the term virtual data lake storage would be more accurate since it's
Okay.
not just a file system, it can pretend to be an object store as well. We've added multiple APIs since then, but virtual distributed data lake storage would be a pretty accurate technical description for this.
Yeah. Okay. Righto. So we're also in the early days. It was all about acceleration. As you've kind of evolved as a company, it's really become about high performance data access layer, which,
Hmm.
when we think about today and we think about how much data is being put into not just traditional databases, the no SQL databases, but data lakes as well, and all the
Hmm.
unstructured data that's out there. Alluxio exists to effectively create a layer that takes all of that and makes it caches it and makes it easily accessible, but also more accessible in a quicker way as well.
Yes, it does.
All right. And how does it? What's the without going into the to the sort of specifics of it? How does it achieve a little bit of that?
Yeah, so we provide, like I said, a lot of times these days when we are talking about the world of machine learning, and that's something that we've evolved into as a company since we started. Like I was saying before, when we started the company, Alluxio was focused primarily on analytical workloads, and even with Spark SQL was where we had most of our early adopters. And since then, we had other frameworks like Trino and Presto and other SQL vendors being used alongside Alluxio. Since then, in the past 3 4 years, especially, different kinds of machine learning frameworks and model training using the likes of PyTorch and TensorFlow has been a major use case for us. And across all of these, the generic thing is that all of the computation engines are data hungry. And especially once you think about the usage of GPUs these days for model training and machine learning, these frameworks are also extremely hungry, no matter where the data is coming from, even if the data is coming from the same cloud, if it's coming across regions in the cloud or a hybrid cloud. All these scenarios demand a hungry computation engine. And that's the first innovation that we have in Alluxio is that we provide this virtual abstraction for data, which sits close to the hungry computation framework. So we use local resources like NVMEs beyond what we started off focusing on, which was memory. So we are able to tier across different media of storage, which is located close to the computation to provide a lower latency and higher bandwidth of access to the computation frameworks on top.
Okay, so in terms of that memory speed I/O, when you're using the memory that's close, so you're using a combination of random access memory, NVMe drives, SSDs. How is there compute that's needed? So would you need a bare metal server? Or would there be a like an EC2 instance that would leverage the software as well to actually get access to leverage the compute component to present that data layer?
Yeah, so there are different modes of operation. These days, the most common mode is that Alluxio is deployed on top of Kubernetes. So we would have
Okay.
pods configured for Alluxio. And the computation and Alluxio could reside on the same Kubernetes cluster. That's the most typical mode these days. So we would carve out dedicated resources for Alluxio, the dedicated CPU and dedicated NVMe storage on the Kubernetes cluster itself, which would then be able to serve the different data-driven applications.
Yeah, okay. So you've got the the application, you've got Kubernetes, you've got all the containerization of that. That's handling the compute and the resources. Underneath that, when you talk about the heterogeneous aspect of it, how would that Kubernetes cluster then talk to maybe a blob storage here or a S3 bucket there or a bunch of disk there to basically aggregate that storage?
Yes, so when we have the different compute engines, let's say running in Kubernetes, we expose different APIs to them. And like we started off talking about, we expose different file or object APIs. So one of those APIs, for example, is the S3 API, which Amazon's S3 API. We also support a POSIX API for model training, especially these days, in which we would expose ourselves as just a mount point in Kubernetes. So if you're familiar with the concept of a CSI driver, a container storage
Yeah.
interface, we provide plugins for Alluxio, and Alluxio just pretends to be a local file system. And that's how different kinds of applications interact with Alluxio. They ask Alluxio, and Alluxio pretends and transparently gets the data on demand from wherever it needs to be accessed from, whether it be a blob storage, like you mentioned.
All right. And then because of the caching, it's doing some predictive analytics or predictive understanding of what data is going to be fetched next. And therefore, that's kind of what's elevated into cache from the underlying sort of slower storage, so to speak.
Yeah, that's accurate. So we do have so we provide a fine granularity of movement of data in this case. So depending on what is being accessed from, like you mentioned, blob store in the example, and Alluxio is exposing it to applications on the Kubernetes cluster that we're talking about. We would move at a finer granularity, and we do also have a prefetching capability based on the data access pattern itself.
Okay. So what's your typical customer like when customers come at you and say, hey, we've got a potential use case for a potential problem? What is that? So I guess, yeah, I'm asking, when a customer comes to you, what are they talking about? And then how do you respond to that with the solution?
Yeah, so we have a few different kinds of solutions and use cases. I would say these days the most common one is people come in to us and say that I'm trying to kick off new initiatives within my organization around machine learning. ChatGPT is all the buzz, and it gathered a lot of it sparked the imagination in a lot of different companies. So coming in with that, translating it into the next set of problems that come up is the first one that comes up is I can't find GPUs to train my jobs and to really get this initiative going. Where do I find GPUs? And even if they have GPUs, the next complaint becomes that my GPU hungry machines are not being fed on properly. So we come across customers even in different clouds like Amazon or Azure who come into us and say that I'm not able to make the most out of the infrastructure that I have. I'm only able to utilize my infrastructure 20 to 30% utilization instead of fully utilizing the infrastructure that I have. So that's one set of problems that we come in with. Other larger enterprises that we come in with is folks who have grown over time and they've accumulated silos of data.
Okay.
So in which they might have gone through acquisitions over time, and they have silos across the organization, which could be spread across different regions of the cloud and also on-premises infrastructure. How do I get the most out of it, both for analytical workloads, but also model training across all of these? So these are kind of, and the other kind of situation which we traditionally came up a few years back was I'm running out of capacity in my data centers. So when a lot of folks, large enterprises especially, when they were operating majorly on premises, they were trying to expand their capacity by either going to a hybrid cloud or going to across multiple data centers.
Okay, yeah, I get it. It makes sense. And in terms of the size and scale of the deployments, what do you see? I know that you've got some fairly large deployment covering kind of thousands of nodes, and in this case, and when you talk about it in the context of Kubernetes, is a node a container, or is a node that serves a bunch of containers?
A node is a container. So when we talk about Kubernetes, typically we are co-located with other services on Kubernetes itself. So we may not have a dedicated node.
Okay. So talk a little bit, you touched on it a couple of times, like the scarcity of GPUs at the moment. We understand that, it's 2023, and, LLMs and AI and ML is quite big this year, right? And if you only have to look at the Nvidia stock price to see that GPUs are hot again. And this time it's not for Bitcoin, it's for this, right? That Nvidia kind of win either way. This may be something to that. But how does Alluxio kind of solve that problem of scarcity of the GPUs at the moment?
Yeah, so if you look at the problem of scarcity of GPUs, one of the things that's happening is it's forcing organizations to find GPUs in data centers or availability zones in the cloud, or even different clouds from where they originally were operating. So let's say you have all of your data in US West 1, in the Amazon region in US West 1, but you may not find all of the GPUs that you need in that same region. So what it's forcing organizations to do is to find different regions, maybe in the same cloud, where you have GPUs available. Some of our customers are even leveraging GPUs that they have on premises. So in their private data centers, just because they want to use GPUs wherever they can. More GPUs means more data processed. More data processed means more accuracy, which has a direct impact on the business as well. The other trend that we're seeing these days is even the smaller GPU clouds, which are out there, that's being a serious consideration, because they also have a healthy supply of GPUs given their size. It's almost the case that smaller vendors have the same amount of GPUs, but fewer, but less demand for it. So that's
Yeah.
another cost-effective way of large enterprising getting hands on GPUs these days.
Yeah, and I've had a couple of bare metal companies on this show, right, talking about the fact is, why do they get into this bare metal space? It's really to offer an alternative to those hyperscalers, which people think are the only way to get a GPU these days. But there's a lot of those people popping up. So you're right. Whether the scare, and maybe it's also contributing to the scarcity that you're talking about, right? Because there's more than just on-prem. There's more than just a public cloud offering GPU services. There's actual now dedicated, because I think people have seen the business model that I think they can make money off. So they're trying to create these companies that are offering GPU-based bare metal hosting or whatever it might be. So with that, talking about the AI part and the LLM, so I'm guessing that where Alluxio fits in is the fact that you're able just to aggregate the data. You've talked about the use cases. You've talked about the fact that you're companies that are coming together through acquisition, different initiatives within companies to get their data that they've been saving and growing for a number of years. How do they make that data work now, and how do they make that work with a LLM over the top of it? In fact, the last guys that I had on the show, Zero Systems, they were all about private in-house. So it's almost like they're complementary to you guys to a certain way, which is quite interesting. Should get you guys talking. But yeah, basically they sit on top and they offer a private way to actually run an LLM model on a set of data. Whereas you're kind of coming from the opposite, aren't you? You're bringing the data to something that can run on top of it and create the model, create the LLM.
Yeah, that's a good analogy. So I wouldn't just say aggregate the data, because aggregation kind of refers to the problem of data silos, which may not be the case when in what we were just talking about. In that case, data might still be in one location, but what people are really getting is the flexibility to move computation away from the data. So in this case, you may move to the cheapest cloud. You may move to where you have GPU capacity. And for the LLM pipelines that you mentioned, it just may mean that you may have your pipeline spread across different locations in the world. So it may make sense for organization to have inference in different regions, but your training data is in a completely different location, and you might have the split between your online cloud and your offline cloud for training. So these are all different scenarios which are naturally split across regions in many cases.
Okay, yeah, I get that. Excellent. So, and in that same sort of notion, we talk about, we've talked about heterogeneous data access layers and whatnot, but how do we deal with egress? Because egress is such a big topic of contention at the moment with public cloud. It's one of the biggest bugbears, right? Where it costs almost nothing to put, well, it should cost nothing to put the data in, but as soon as you've got to pull that data out in whatever way, those public clouds that are going to charge you for everything that you pull out. And it's usually quite an exorbitant fee. It's usually a hidden fee. Well, it's not hidden, but it's always a shock still to people, because I think companies still haven't, or organizations haven't wrapped their head around the fact that it's my data. Why can't I get it out for free? It's like they're almost holding it ransom. In fact, that's an analogy that I've heard on this show from someone. It's just like these public clouds almost hold your data to ransom because it costs you to bring it out, which is an interesting analogy. So what do you think about that? And how does Alluxio solve that particular issue?
Yeah, I think that the cloud providers are always incentivized to move the organization's data into their storage, because it naturally drives consumption of all different kinds of services in the specific cloud, like you mentioned. And egress has been a topic of conversation for some time now, especially once organizations were operating heavily in a hybrid cloud environment. Where we come into that situation is, let's say you have your data moved to cloud A, but like I was saying, that the initial set of scenarios that we came across was you want to access the data from on-premises, or you want to access it from a different region, as we were talking about in the scenario of your organization might have gone through acquisition.
Yeah.
So where we began with analytical processing, like I mentioned, we act as a cache between your compute and your data, no matter if it's coming across different regions. So to avoid egress fees, one of the common methods that was employed before was actually to set up a copy job. So initial solutions would be as simple as Hadoop this CP copy from region A to region B, and then access in region B, because people knew that egress is going to be a challenge. So directly accessing from region B data which resides in region A wasn't feasible because of egress. So we eliminate this manual hacky workaround by providing direct access in region B, and caching on demand. And the access pattern for different analytical workloads and also model training is pretty high. So we see that our cache hit ratio is around, used to be around at least 80-85% for typical SQL workloads. And for model training, it's even higher, because the same set of data is accessed multiple times. So in model training, for example, different epochs, I would read the same training data again and again, and we've seen as high as 99% cache hit ratios with Alluxio. So that's one of the ways we eliminate egress fees.
So going back to the manual analogy or example that you used, so you've got Hadoop copy to Hadoop A to B. Don't they have egress costs in that copy job as it is, or are you saying because it's a one-time copy, you're only dealing with one set of egress charge from A to B, and that's kind of been accepted? Whereas what Alluxio does is even stop that one-time egress charge, or it definitely stops the tooling, and like you talked in the model data, LLM data, you're accessing the same model data all the time, right? So you're going to have repeated costs for that data going from B to A or A to B. So is that really what it's stopping? It's stopping that multiple access issue as opposed to that single copy that you talked about to start with.
Yeah, so in the single copy world, the egress fees that's only the hit is taken only once
Mm-hmm.
when you copy manually. But the problem with that approach is you need to identify what to copy, and
Yeah. Okay.
which itself is a problem. What we've seen with most of our customers is that anywhere between 1 to 5% of the total data is what's being accessed 99% of the time. Uh,
Yeah. Okay.
so identifying that was a big problem, and that's why I said this is a fairly data engineering heavy exercise to identify things first and then copy. And that's also what we eliminate. So not only do we provide the simplicity in which you could do the same job with one data engineer instead of four, uh, because you just need to point compute to data and Alluxio will go get it for you. And then for repeated accesses, what happens is you don't end up moving more than you need to. Uh,
Yeah. Yeah. Yeah, and that makes total sense now. Yeah, and I think that clarifies it for anyone listening and trying to wrap their head around it. That explanation is perfect in terms of the value prop for it. So, yep, I get that. It's really awesome from that point of view, and it completely makes sense. And the value is there because at the end of the day, containing cloud costs is a business imperative these days, right? Especially when we're talking about data at huge levels, right? Like the amount of data is always growing. The amount of data that we want to analyze is getting bigger and bigger. So we want to be able to optimize, the path from A to B as much as possible. So if we can do that at speed as well, that's an added benefit.
Yeah, definitely. So we do work with some of the largest organizations in the world. On our We have collaborations with Meta, Uber, and
Wow.
many large names on the enterprise side as well. So like you said, the amount of data that we're talking about is no small number. We're often talking about hundreds of petabytes.
Yeah.
Actually, that reminds me, when I was in grad school, we were designing storage systems as part of Carnegie Mellon's Parallel Data Lab with petascale storage in mind. So the big thing then used to be, let's design a storage system which can store 1 petabyte of data. And now
Yeah.
we are talking hundreds of petabytes, if not more, at the
Yeah.
largest organization.
It's crazy how that's moved on, right? And yeah, and I don't think it's any surprise that you're Alexio, the names that you mentioned, Meta, Ubers, and whatnot. But if you've come from that Berkeley lab where you've talking about Mesosphere, you're talking about was Databricks today, I don't think it's very surprising that potentially people haven't heard of you guys so much in certain areas of IT, but they should understand that the pedigree of where you come from means that you're doing some pretty serious work, right?
Yep, definitely. We're really proud of what we built as a company here at Alluxio. It's been a great journey, and we're only, I think we're at the cusp of something really big, and hopefully everyone has heard of us very soon.
Yeah. Hey, and just talk about the open source side of the equation because I think that's important to understand how that fits in with Alluxio.
Yeah, so open source has been a core part of our strategy from day one. Open source gives us a lot of different things. The first is open source. If you look at the community these days and where the innovation is happening, the innovation is definitely all is in open source. So it's very hard for a proprietary technology to keep up with advancements in this complex ecosystem that we're all
Yeah.
all part of. So that's why we leverage our open source to have close collaborations with the big tech leaders. So we talked about the Ubers and the Metas of the world, and that's one of the the use of open source for us, in which we are able to really push advancements in technology, really cutting edge technology across the entire globe by these collaborations. And without these open source collaborations, we would not be in a position to do that. In addition to that, open source also gives us a testing ground for our technology. the more widespread the adoption of the technology is, we are really able to make sure that we have something which can um, be used for business critical applications in which going down even for, let's say, 15 minutes in the year is not an acceptable scenario. So we need to be battle tested. And the only way we really get battle tested is by leveraging open source and making sure we're adopted across a variety of different scenarios.
That's been an interesting topic of conversation. I think I've come across this year in a number of different formats, whether it be hearing Mark Zuckerberg talk about AI and how, the pull and throw of, do you open source AI? Do you have it closed source? To a certain extent, the same argument is held for you guys, right? And when what you just articulated, and the fact that if you got it open, then you've got more eyes on it. And if you've got more eyes on it, you've got more opportunity to weed out the potential issues, the bugs, at scale and at human quick scale, right? You're using the totality of the open source community as an AI as such as well, to be able to work and actually work on the code and get it to a point where you can trust it for those tier one critical applications, which is so important. So it's funny how we've this talk this year that's definitely shifted towards that open source mentality as a good thing, as opposed to what it was seen maybe 10 years ago, where it was almost touted as a bit of a way to get a science experiment out, and you shouldn't really trust the open source community because it's a bit slack and it's a bit open for that particular reason, right? Because it isn't controlled. So that is quite interesting, but it fits with the narrative that I think has been, pushed this year quite a bit.
Yeah, definitely. So open source is definitely serious business, and I think it's very hard to survive in the industry that we are in without being an active part of the open source community. And open platforms, without open platforms, I definitely feel it's very hard to really push the advancements in technology that we all love and care about.
Yeah, and so obviously from the business model you guys are having, you've the way that you deal with the open source componentry is that you've probably got some enterprise support and whatnot worked into the product as well. Is that how you leverage the open source, but obviously keep the business going at the same time?
Yeah, we do have enterprise differentiation services as well, functionality differentiation and services that we provide on top of the open source project, and then that's the core of our business as well. So
Awesome.
open source, what we provide, the support that we provide on the open source side, it's limited to some extent, and what that's where for folks who need the skill set to manage their clusters, we really push them towards enterprise.
Awesome. And hey, just to finish off, Alluxio as an innovative company, right? And obviously ambitious, where you've come from, quite ambitious. The co-founder's ambitious. What's your future plans? Like, what are the upcoming features or enhancements in the pipeline for Alluxio?
So we as a company, we want to be the entry point for data for all data-driven applications. That's a big statement. So we started off in analytics, and we are going. We have made extremely good progress on the machine learning front. We've seen us being used for that. Beyond this, we are only reaching out to provide more services and more SaaS services built around the core product itself,
Cool.
which makes it easy for people to use the cool technologies that we have.
Excellent. Well, look, I'm looking forward to seeing what Alluxio does, in the future. I think for those that don't know about Alluxio, it's a really interesting one to go and take a look at. You can go to the website. I'll link to the show notes, all of, the open sources, the getting started guides. There's a whole heap of great documentation on the website. So, thanks a lot for the great conversation. I think it was a really interesting angle that complemented what I've talked about in this episode, almost in the inverse, the other side of it, which is the data management. So thanks a lot for that. So just as a final reminder, you can find myself at Anthony Spiteri or at GTwGT podcast or at GTwGT.com. And just as a final reminder, once again, if you aren't subscribed or are new to the show, go to the web. Thank you to Adit. Thank you to Alluxio. And we will see you next time on Great Things with Great Tech.